All right, today we're going to do lesson 9.5, and we are going to learn how to use the quadratic formula. Now, a couple days ago, really last week, we talked about quadratic equations. All right, so I need you to think back for just a second to quadratic equations. We talked about what the graph of a quadratic equation would be. Does anybody remember? All right, Abby.
It looks like a U.
It's a U-shaped. It's called a parabola, but she's exactly correct. So what we're going to do today is we're going to figure out how to find where the parabola would cross the x-axis. Hey, when we can't graph a parabola because you haven't learned that yet, I haven't taught you that yet, how do I find out where the parabola would cross the x-axis? One way I can do that is to use the quadratic formula. All right, so that's what we're going to look at today. Now, if you look at this formula, there is a part of it that you have already learned. Does anybody recognize a part of this formula that we have already dealt with and already worked with? All right, Andrew.
B squared minus 4ac.
Okay, and what is that underneath? A radical. Okay, very good. So we have already learned in lesson 9.1 how to solve the square root of b squared minus 4ac. So let's review for a second. When I plug a value into b and I square it, will the first number under the radical ever be negative? No, because I'm squaring it. So if I plug in a positive number and square it, I get a positive answer. If I plug a negative number in and square it, I get a positive answer. So we already know that the first number under the radical will never ever be negative. All right, what about the -4, the a, and the c? What are we doing with those three pieces of the problem? Class? We're multiplying them. All right, there is no sign between the -4 and the a and the c, so we are multiplying them. Okay, so we already know how to deal with that portion of the formula. But let's look at the other parts. Remember what I just said. As we're solving the quadratic equation, we're trying to find where the parabola would cross the x-axis. So that's why the beginning of this problem says x equals. We are trying to solve for x. All right, now the next piece we got to pay really close attention to is this negative b right here. All right, really we read that as the opposite of b. So we got to be really careful because we've got to remember that negative is already in the problem. And so if we plug in a positive value, what kind of 2 will we end up with? What kind of 2 will we end up with if we plug a positive value in for b? A negative, all right? We plug in a positive 2, we actually end up with a -2 because of the negative sign in the variable. All right, now what happens if I plug a negative value in for b? What do I have? I get a positive because I have a double negative right here, and so it actually comes out to be a +2. So you got to be really careful. There's already a negative in the formula, so don't get confused when you're plugging in a negative value. All right, and then lastly we have the denominator. What are we doing to the 2 and the a? Look at it. What are we doing? There's nothing between the 2 and the a, so what are we doing to it? We're multiplying it. All right, very good. So the next question is, okay, where do I get the a value, the b value, and the c value? Because as you wrote down your examples today, did I give you any of those values? No. So you've got to know, okay, where do I get those values? And that is where standard form comes into play. Before we can find a, b, and c, we have to make sure the equation is in standard form. So look at standard form. X squared, x, and your constant will all be on one side of the problem, and it will be set equal to 0. That is what makes it standard form, because look, once it's in standard form, look where a is positioned, look where b is positioned, and look where c is positioned. A is the coefficient of x squared, b is the coefficient of x, and c is my constant. So once it's in standard form, pulling out a, b, and c should be really, really easy. All right, so let's look at example number 1. It says, use the quadratic formula to solve the equation. So our first question is this in standard form? Charity, is this problem in standard form?
Yes.
Yes. X squared, x, and our constant are on the left side of the equal sign, and the whole thing is set equal to 0. So that means we should be able to pull out what a equals, what b equals, and what c equals. So Charity, what does A equal?
1x squared.
Now be careful, look back at standard form, all right? The A is positioned as the coefficient of x squared. So the whole term is not my A, only the coefficient of x squared is A. So what's the A value for this problem? 1. Very good. Remember, there's an understood 1 right there. So my A is 1. What's my B value? 9, because it's the coefficient of x. And then what is my C value? 14, because the constant in this problem is 14. Now I want you to go ahead and circle just so these stand out, okay? Not because they're my final answer, but because I want them to stand out from the original problem. Now, the best way to memorize the formula is to write it down. So that's the next thing I want you guys to do. X equals, okay? Let me pull it over just a little bit. Okay, x equals negative b plus or minus. Now, we didn't really talk about that plus or minus, but we know that's a plus sign and that's a minus sign. So we'll get to that here in just a second. But plus or minus b squared minus 4ac, and that is all over 2a. So we're going to write that formula down just so we can memorize it. Now notice this. This is one thing I see a lot, and I want to make sure you guys don't do it. Should my fraction bar be pulled all the way over here underneath my x? No, that's a completely different side of the problem. So make sure you keep the fraction bar from the negative b to the right. Okay, don't cross over onto the side with x. Now, let's plug those values in. I want everybody telling me as we go through this what values we're plugging in. So we have the opposite or negative. What are we plugging in for b? 9. Plus or minus the square root of. What's going in place of b? 9. Notice everything's going in parentheses. What's going in place of a? 1. And what's going in place of c? 14. All right, we'll pull that radical sign over. And then we have 2 times, what's going in place of a? 1. All right, so far we haven't done anything too difficult. We found a, b, and c. We wrote down our formula, and we've plugged our values in. Now, based on what we've done already in this chapter, where would be the best place to start working? What is it?
In the radical.
In the radical. We already know how to work the square root of b squared minus 4ac. So that's exactly where we're going to start. So let's pull down what we have not used. Am I pulling down a negative 9 or a positive 9 right there? Negative. Very good, because I plugged in a positive 9. So it's going to come down as a negative 9. Bring down that plus or minus. And then let's do the work under the radical. Now, Tito, underneath the radical, I have to do what first? If I'm following my order of operations. What? Okay, do I have any work in the parentheses, though, to do? Look inside the parentheses. Is there any work to do? All right, so move on to the next thing. What's after parentheses? Okay, do I have exponent I can work with? Yes, what? Good. What is 9 to the power of 2? 81. Good. Now, let's focus on this part of the problem, Tito. How many negative signs are there in that portion of the problem? Which is an odd number. So is my answer right there going to be plus or is it going to be minus? It's going to be minus because we have an odd amount of negative signs. Now we can just focus on 4 times 1 times 14. What's 4 times 1 times 14? Okay, we got 56. Good. And then if we put all of that over, what's 2 times 1? 2. Very good. All right, now you guys keep working down. I'm going to come back up here to the top of the screen. X equals negative 9 plus or minus. And now let's do the math under the radical. What is 81 minus 56? 25. Good. Over 2. Now, at this point, we don't really know what to do. Okay, we haven't, well, we've gone one step further. What is the square root of 25? 5. Okay, so really it's negative 9 plus or minus 5 over 2. This is a part where we would get to, and right now we don't know what to do. All right, but let's talk about that plus or minus sign. How many times am I going to have to work this problem out because of that plus or minus sign? Twice. So here's what we're going to do. We're going to write x equals negative 9 plus 5 divided by 2. And then we're going to try beside it to do x equals -9 minus 5 divided by 2. All right? The best thing for us to do is to write those two little equations side by side. So x equals -9 plus 5 divided by 2, and x equals -9 minus 5 divided by 2. So let's do the math. What is -9 plus 5? -4 over 2. And right here, what's -9 minus 5? -14 over 2. So x equals -2. And x equals -7. Awesome. So when we solve the quadratic formula, how many answers are we going to have? 2. Okay? Every time we're going to have 2 answers because the plus or minus causes us to have to work the problem twice. All right? Now let's talk about what we've just found. We talked about it a little bit earlier. Let's talk about it again. X equals -2 and x equals -7. If I were to go back and graph this equation, what do those two values tell me? Think about that parabola. I go back, I graph the parabola. What have I just found if I found out that x equals -2 and x equals -7? Trent.
That it goes like this all in this quadrant over here, and that's where.
Okay. Good. Give me a little bit more specific. Cole?
It's where the u intersects the x, the point or whatever.
The x-axis. Very good. Okay. What we have found is the two x-intercepts. We found where that parabola would cross the x-axis. So these are our x-intercepts. Now, it would not be a bad idea for you to write that in your notes. All right? If you don't think you can remember, what are we finding when we solve the quadratic formula? We're finding the x-intercepts of the parabola. Now, the reason that's important is because look at example number 2. It says find the x-intercepts of the graph of the equation. So if that's all the instruction you see, how do you know what to do? What are we going to use in order to find the x-intercepts of the graph? We're going to use the quadratic formula. But if you don't know that the quadratic formula is helping you find the x-intercepts, then you might not know what to do when you see these instructions. So that's exactly correct. When it says find the x-intercepts of the graph, we're just going to use the quadratic formula again. So, question, is this in standard form? All right, we say no, but let's look at it. Are my x squared, my x, and my constant, are those terms all on the same side of the problem?
Yes.
But they're set equal to what? Y instead of 0. But guess what? All we have to do is rewrite this and replace y with 0. So now let me ask the question, is this in standard form? Yes, it is. So now we can pull out A, B, and C. All right, Diana, what is my A value this time? -4. What's my B value? 8. And what's my C value? Very good. So it was in standard form. So A was equal to -4, B is equal to 8, and C is equal to -2. All right, let's write our formula out. X equals -b plus or minus the square root of b squared minus 4ac. I should see all pencils moving all over 2a. Is writing the formula out the most fun thing ever? Absolutely not. But it's the best way for you to memorize it. The more you write it, the more you'll memorize it. All right, now let's plug in our values. So x equals negative, what's going in place of b, class? 8 plus or minus the square root of what's going in place of b? 8. Remember, my b is positive 8. All right, minus 4 times what's a? -4. I need more help. What's going in place of c?
-2.
Very good. All right, we'll extend that radical out. And then this is all over 2 times what? Okay, 2 times -4. All right, what are we going to do next? What portion of the problem, Maya, are we going to work next? All right, what's under the radical? So, am I bringing down a positive 8 or a negative 8? Good, it's still going to be a negative 8 plus or minus. All right, Maya, under the radical, what do I do first? Which is? Very good. All right, if I look at this portion of the problem, is my answer going to be positive or negative? Why negative? Good. There are 3 negative signs, which is an odd amount, so my answer will come out to be negative. And then what is 4 times 4 times 2? 32. Awesome. Over? Negative 8. All right. Everybody with me so far? All right. You guys keep working. I'm going to have to pull this up here back at the top. X equals negative 8 plus or minus. Hello, when we do the math on that, 64 minus 32, what do we actually get? 32. All right, awesome. Now, unfortunately, this gets a little bit more complicated because is 32 a perfect square? No. So what method are we going to use to find or to simplify? Very good. All right. What prime number, Alex, will go into 32? 2. All right. 2 goes into 3 once with 1 left over. 2 goes into 12 6 times. Alex, keep going. What goes into 16?
2.
How many times?
8.
What goes into 8?
2.
How many times?
4.
What goes into 4?
2.
How many times?
2.
Do I keep going or am I done?
You're done.
Good. I've reached a prime number, so I'm done. What is my next step, Jonadab? Pair them. I got a pair of 2's right here. Got another pair of 2's right here. So what happens, Jonadab? This pair of 2's becomes a what?
2.
Just 1 2. This pair of 2's becomes just 1 2. And what am I supposed to do when I have oh, hold on. I forgot when I rewrote the problem, I forgot to put it over negative 8. All right? Bring that denominator with you every single time. Because exactly what I just did is going to happen. If you don't bring it every time, you're going to forget it. And you will forget it at the end when you're trying to finish solving. So bring the denominator with you every time. All right, so we have x equals negative 8 plus or minus. Now, Jonadab, what are we doing to the 2 2's that just came out from under the radical? Good. And what was left over and needs to go under the radical? 2. The 2. All right, awesome. Over the negative 8. Okay, so x equals negative 8 plus or minus. What's 2 times 2?
4.
4 times the square root of 2 over negative 8. Now, I know it's getting squishy in here. All right, but look at the problem. I am very, very sorry that this does not come out to be a perfect square, but you need to know what to do anyways, so let's look at this. This is a fraction, and what are we supposed to do with every single fraction that we encounter? Reduce it, okay? We've got to put it in its simplest form. So here's what you have to understand. I can only simplify the fraction if every single piece of the problem will simplify. Now let's talk about when I say pieces. Remember, we can only work with things that are outside of the radicals. So that would be a piece. This would be a piece because that 4 is outside the radical, and this would be a piece. Can those 3 pieces, can all 3 pieces be simplified? Then we can simplify this problem. All right, so we have x equals, all right, x equals, what goes into negative 8, 4, and negative 8? 4. Very good. So negative 8 divided by 4 is what? Negative 2. Plus or minus, 4 divided by 4 is 1. Bring down the square root of 2. And negative 8 divided by negative 4, I'm sorry, negative 8 divided by 4 is negative 2 again. Now, can I reduce the problem again? No, because look, here's a piece, here's a piece, and here's a piece. Can all 3 pieces be reduced? No. Then I can't reduce any further. Now, there is one other thing I can do. Does anybody else notice something about this problem? Aliana.
You can take out negative 2 because they're the same.
Okay. Well, we could if we were going to split this up into 2 fractions, but we're not actually going to go that far. So we're kind of stuck at the spot where since all 3 pieces don't reduce, we're not going to reduce any further. However, we do have a negative divided by a negative. And what's a negative divided by a negative? A positive. All right? So these two become positive 2's. Now, remember, we have to write down 2 answers. So anybody want to take a stab at what our first answer would be? We're not putting it in decimal form. We're going to leave it in this form, but we have to write down 2 answers. So Trent, what would my first answer be?
X equals 1 square root of 2.
All right.
Or just square root of 2.
Well, here's my question. Where does, if I'm reading left to right what I already have, where did that first 2 go?
It divides with the other 2.
But that's what we're talking about. We would only divide if we were going to split this up into 2 fractions, and we're not going to do that. We're going to leave it just like this, but we got to write the answer down twice.
So 2 plus 1, the square root of 2.
Okay?
Over 2.
Over 2. All right. And then my second one would be
X minus square root of 2. Or 2 minus square root of 2 over 2.
very good. All right. Now, again, like I said, there is one step further we could go, but we're not going to go there just yet. All right. We're going to leave it just like this. So we have 2 plus the square root of 2 over 2, and then 2 minus the square root of 2 over 2. All right. So be very careful when you are reducing. Remember, every single number outside of a radical has to be able to reduce in order for you to reduce. All right. Any questions on this one? All right. Now, last one, I want you to go to the back of your notes, go to the flow chart. We're going to fill the flow chart in because this is one of the best ways for you to review. This takes you step by step on what you should do, and this has even the little pieces of information that you need. All right, so let's look at the problem. Negative x squared equals 2x minus 3. So the first question I have for you, and the paper even says, is my equation in the right form? No. All right, look at your equation. Negative x squared equals 2x minus 3. Is it set equal to 0? And of course the answer is no. So follow the arrow on your flow chart that takes you to no, and rewrite your equation so it is equal to 0. So first thing you want to do in that box, rewrite the problem. So negative x squared equals 2x minus 3. You want to rewrite that problem. Now, what is the quickest and the easiest way to get this into standard form? There's a couple ways you could do it, but my question is, what is the quickest way? Hayden? Add x squared. 2 reasons. If I add x squared, I've only got to move one thing. Second of all, we always want to try to get a positive x squared term. All right, you never want a leading coefficient that's negative if you can help it. So we are going to add x squared to both sides. So go ahead in your box. We're going to add x squared to both sides. So Hayden, if I add x squared to both sides, what do I get? What do I get on the left side of the problem? 0, because this cancels. And what does 0 equal?
X squared plus 2x minus 3.
Good. We got to put it in descending order. So 0 equals x squared plus 2x minus 3. Now, follow the arrow to the left to step number 2. It says find the necessary values. Remember, I said this is going to be a good study guide. It says, what is a, or the coefficient of the x squared term? What is b, the coefficient of the x term? And what is c, the constant term? So, Hayden, what is your a value? 1. Good. There's an understood 1 right there. B equals 2, and c equals -3. All right, so everybody fill in those blanks on your flow chart. Now follow the arrow to step 3. Plug it in. Once we've got those values, we're going to plug it in. And they were nice enough to even give you the formula. X equals -b plus or minus b squared minus 4ac. Now do you notice over 2a? Do you notice what they have you plugging those values into? What are they having you plug those values into? Parentheses. All right, so in place of b, we're plugging a what, class? 2. Good. Plus or minus the square root of, in place of b is another 2. Squared minus 4, what's going in place of a? 1. And in place of c?
-3.
Awesome. Let's pull over that radical. And then, of course, it's over 2 times 1. Awesome. All right, now follow the arrow. Step 4, it says tidy up. So first we're going to simplify any double negatives. That's going to be right here in the problem. Do we have any double negatives? No. So we're going to bring this up here. I am going to put x equals -2 plus or minus. Now it says to calculate the discriminant, and that's a very important word because that's going to help us in tomorrow's lesson. The discriminant is the b squared minus 4ac value inside of the root. So let's work that out. All right, Sam, what would we do first?
You would do the exponent.
Good, which is what?
4.
Good, 2 squared is 4. Is my answer going to be positive or negative? If I'm looking at this piece, how many negative signs are there?
2.
Which is even, so is it going to be plus or minus?
It's going to be plus.
Plus, and it's going to be plus what?
12.
12. Awesome. Over. The next step says simplify the denominator. So what is 2 times 1? 2. Awesome. It then says rewrite the equation. So let's go ahead. X equals -2 plus or minus the square root of what? Class?
16.
16 over 2. Now, carry that down into step number 5. Okay, it says simplify the root. We're either going to find the perfect square of 16, or we're going to use what to simplify the square root of 16? Upside down division. So let's look at this. What is the square root of 16?
4.
Thank you, Jesus, right? It's a whole number. So -2 plus or minus 4 over 2. Now follow the arrow carefully over to step 6. It says do the plus or minus. So calculate the two versions of the numerator by doing the plus or minus. So Charity, what is my first equation going to be?
X equals -2 plus 4 over 2.
All right, so the first time through, I'm going to use the plus. And for the second one, x equals -2, Charity? Minus 4 over 2. All right, so those are the two in step 6. In the box for step 6, those are the two problems that you want to write down. X equals -2 plus 4 divided by 2, and x equals -2 minus 4 divided by 2. And lastly, follow that arrow down to step 7, simplify. So what is -2 plus 4? 2, and 2 divided by 2 is 1. Awesome. And then -2 minus 4? And -6 divided by 2? -3. And again, let me ask you, what did we just find? X equals 1 and x equals -3. What did we find? The x-intercepts of the parabola. If we were to graph this problem, it would cross the x-axis at 1 and -3. All right, awesome job.